So part 4 is necessary for those people who don't realize the major scientific discovery has been made. Stellar evolution is planet formation. Of course, I'm ridiculed a lot for it online, but you'll see why here it's very important that we sort of ignore the ridiculers. Ilya Prigogine. This guy, 1977 Nobel Prize in Chemistry. That is one smart cookie right there. He earned, I don't want to say won, he earned the Nobel Prize. I guess the Nobel laureate people, they have their heads screwed on tight for this guy, because this guy was a very big deal, and he's essential to this theory. It's very centralized to it. He earned it for his contributions to non-equilibrium thermodynamics, particularly the theory of dissipative structures. Hi, Celeste. But anyways, this guy, Ilya Prigogine, was the guy that basically said this in a nutshell. The probability for order to arise from disorder is infinitesimal according to the laws of chance. The formation of ordered, dissipative systems demonstrates, however, that it is possible to create order from disorder. The description of these structures have led to many fundamental discoveries and applications in diverse fields of human endeavor, not only in chemistry. In the last few years, applications in biology have been dominating, but the theory of dissipative structures has also been used to describe phenomena in social systems. The theory of dissipative structures also applies to astrophysics, and that's where I come in. It's where Anthony Abruzzo comes in. It's where Daniel Archer comes in. That's where we all come in, you guys. This is a big deal. This paper right here, I did a review of it. Of course, I went over a bit more, typed out a bit more. Tying together the gravity principle of life formation to dissipative systems concerning life formation in the general theory and self-organization. In a nutshell, if you want to turn this video off and you don't want to hear what I have to say, the stars are the dissipative systems that form life. That's what they do. A star takes all of its chaotic structures, and since it's not an isolated system, the entropy does increase, but the entropy is lost through its radiation, through its mass loss, and eventually it creates order out of that disordered structure. And of course, it becomes more and more complex as the star evolves. So the end result is that all the energy of a star's gravitational collapse is eventually transformed into life itself at the very, very, very end result of the star's evolution. And that is a big, 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 big deal. I don't think this is going to be recognized in its time. It's probably going to take a good 50 years. I'll be 85, 50 years from now. Hopefully I live to be that long. Ilya Prigogine died when he was 86. May 28, 2003. So about a month and a half before I even went into the Marines, I was like 18, 19, 18. But not worried about if people recognize it on the long scale, the long term. But I just hope there are at least a couple dozen people that see this. And for those that have been sticking around still, I'm going to go ahead and read this out to you. According to the general theory, most stars evolve into life-hosting planets, thus stellar evolution is planet formation. Some stars host life for longer periods of time with greater biological complexity than others, and some never form life at all. That's very important. Not all stars form life. The cutoff for such calculations will eventually be reviewed and worked out inside of the Taylor threshold in light of the mobility, gravity, and container and time principles of life formation, of course. Those are in other papers, but I'll just go over this one right now. To begin, what we have is a previously not considered mix of ideas that set the stage for the beginning of life. Number 1, life is formed from the energy of a single star's evolution. Life is a process that self-organizes from the energy of an evolving star directly. Number 2, life is extremely complex, many magnitudes greater than human imagination can really comprehend. We cannot really comprehend our own stupendous complexity. This means we have to chop it down to the smallest parts at all levels of of abstraction and work all the way up to fully comprehend. Basically, the reason why I said that is people need to not think of life in terms of chopping it up, but not only do you have to chop it up, you have to reach up higher levels of complexity of abstraction to get the complete picture. Just chopping it up as everything is DNA or everything is the way a protein folds is not doing it any justice. You have to look at all levels of abstraction because it's an enormous process. The general theory, I named it the general theory of stellar metamorphosis, the general theory, because there's a hell of a lot to it than what meets the eye. But a lot of the ridiculers, they don't want to consider that. But of course, we know better. Number 3, placing the probabilities of life forming from ionized individual atoms all the way to extremely complex organisms such as a cat tells us we are dealing with matter from a multifaceted view. This means probability calculations will overlap on multiple avenues. When you do probability calculations for the molecules becoming more complex as the star evolves, you can't just look at the star as it currently is, as is. And that's the problem with the mentality of a lot of astrophysics people, is that they look at a star as it is, and they do calculations based off its mass, and then they abstract away all the meaning that's actually there. They abstract away the fact that it's a dissipative structure. They abstract away the fact that hydrogen combines with oxygen forming water. They abstract everything away, including the mass loss that happens over its lifetime. And they also abstract away all the evidence of various stars in multiple stages of evolution that we're finding mislabeled exoplanets. So basically what we're dealing with here is a very different worldview in a nutshell for that one. Number 4, pure randomness would never form life. There has to be a direction for all the chemicals to synthesize and replicate, meaning there has to be some overreaching, stationary, extremely stable, long-term force that can mix huge amounts of material together constantly for billions of years, which means gravitation removes randomness during the formation of life, only it is directed by the large-scale dissipation of a single star's energy, meaning it is not pure randomness. Like I said in the previous statement, and this is the big thing here. I'm going to repeat it over again. The probability, this is from the Nobel page, the probability for order to arise from disorder is infinitesimal according to the laws of chance. It's true. But when you include gravitational collapse in there, you remove the chance. You make it to where a star can make life. It takes those chemicals and makes them more complex as the star gravitationally collapses on itself. Number 6, to form life, a dissipative system greater than life itself is required, so that energy remains in boundless supply for billions of years. The star is the object that makes the life. It takes an incredible amount of energy to form life. Incredible amount of energy and incredible amount of time. And that basically is self-evident. The Earth is 4.5 billion years old. And the Earth was something as massive as the sun. So both energy and time, they're all there. Number 7, stars are dissipative systems, which are open thermodynamic systems that form life, but since life is quite complex, it is required that the dissipative system die down considerably on par with the amount of complexity that has risen. In other words, the more energetic the system, the less complex the molecules will be found, and the calmer the system, the more complex molecules will be found as a general rule of thumb. So when you have stars in various stages of evolution, such as Jupiter, yes, you'll find some more complex molecules in there. But the rule of thumb is that the more complex molecules will be found in something that's less active, such as Neptune or Uranus. And they have less complex molecules inside of their atmospheres and internal structure as the Earth. The Earth has human beings. It doesn't get any more complex than us. We're the apex of complexity. We're so complex that one day I think we're going to be growing and designing life ourselves because we'll be master geneticists, which is kind of scary. I'm sure China is already trying to do that. Oh, communists. Anyways, there's that. Number 8, self-organization, also called in the social sciences spontaneous order, is a process where some form of overall order arises from local interactions between parts of an initially disordered system. is what we're talking about. The disordered system is the young star like the sun, and the ordered system is the highly evolved, differentiating, life-hosting star similar to the Earth. This, of course, is placing the order inside of the organisms that contain multi-level organization, such as organelles from complex molecules, cells to tissues, organ systems, yada, yada, yada. 9. The self-organization process happens with stars because sufficient energy is available, not needing control by an external agent. Of course, self-organization means it's self-contained. You don't need energy from an outside system. And this is very important to understand as well. A star's own gravitational collapse produces the energy required for the energy transformations required for life to arise. This firmly neglects the assumption that the sun is the total ends and means to life on Earth. If it is the Earth that is the self-organizing system which created its own life, from its own gravitational collapse, completely independent of the sun, as do all stars which evolve slowly enough. This is very important too. It removes the sun as being the prime driver for all life on Earth, which means it opens up the meat of the theory, being that the Earth hasn't always been in orbit around the sun. The Earth was orbiting other stars in its past, and the systems that we see now are randomly assembled. So the idea that all the evolving stars in our system all formed around the sun at the same time, right out the window. 10, of course, so does the credibility of all astronomers, but it's very hurtful to say that. 10, self-organization is often triggered by seemingly random fluctuations amplified by positive feedback. The positive feedback loops are sustained by the star gravitationally collapsing over hundreds of millions of years. This means gravitation removes the randomness. It is more a directed randomness. And here's my analogy for that, for directed randomness. It is a mix between pure capitalism and government oversight. So it's not that life arises from pure randomness. There's a larger encompassing system that allows for smaller systems to be random in their own way, but still have a prime directive, if you will. And that's one of the very big things too, is that life itself will arise. Stars force life to exist in the universe, which means we were going to happen. 100%. Life is going to happen. It forces itself to exist because that's the way the stars, that's the way they evolve. They force life to occur because of their properties and their dissipative systems. They can take that randomness and make it into a directed goal. I don't know if that makes any sense. Ooh, this is long paper. Okay, number 11. The resulting organization is wholly decentralized, distributed all over the components of the system. The system, in the case of stellar evolution, is that life arises all over the Earth and in the oceans of the evolving star. This is why life is all over the surface of the Earth. Life arises highly decentralized. It did not start at a single point on the Earth. And that's also, you can branch that out. It isn't that the panspermia idea where a single asteroid came in and seeded life and then that life spread out from a single point. No. The Earth itself is the entire decentralized system that forms the life itself. So similar molecules could be formed all over it, which then interact with other types of similar molecules, and then certain complex things arise right here, and then they migrate about, and then they form other complex molecules over here, and they migrate about. It's very decentralized. There's no real, this is where it all happens, this is where all the life began, and then it just popped up. Like, it isn't like a giraffe evolved right here. It's the preconditions for the giraffe to be right there have happened all over the Earth. So yeah, that's basically it. Number 12, as such, the self-organization is typically robust and able to survive or self-repair substantial perturbation. This is why life comes back after extinction events. So regardless The Earth had orbit changes, and the process of life formation and evolution is sustained because there is always sufficient energy available. If there were an extinction event and no extra energy could be provided, then all life would die, as is the case of Venus, Mercury, Mars, and the Moon. So what that means is there needs to be enough energy of the star for, if there were to be an extinction event, the life would then arise back up again. But that's an extreme abstraction, but basically that's what it means. So Earth did have extinction events, but the life obviously came back because that's the way the system is designed to begin with. It's a self-organizing system in of itself. So if there's an extinction event, it's still going to self-organize and life's still going to come right back again. Life finds a way. 13, chaos theory discusses self-organization in terms of islands of predictability and a sea of chaotic unpredictability. I don't know what that means, to be honest. Number 14, self-organization occurs in many physical, chemical, biological, robotic, and cognitive systems. Examples of self-organization include crystallization, thermal convection of fluids, chemical oscillation, animal swarming, neural circuits, and stellar metamorphosis. Well, stellar metamorphosis includes crystallization. The core of the Earth is crystallized. The very fact that Earth forms crystalline structure in the form of the crust, rocks and minerals, of course, is a dissipative structure system. Thermal convection of fluids, storms on the Earth, storms in Jupiter, storms in the Sun, storms in Neptune, storms in Uranus, storms. Chemical oscillation, of course, there's chemical oscillation. The dinitrogen dioxide, I think, chemically oscillates in the Great Red Spot on Jupiter. So there's still chemical oscillation there. There's chemical oscillation inside of the Earth. I can't think of an example off the top of my head, but it's there. And that's what dissipative structures do. They oscillate a lot. And also they oscillate with phase transitions as well, which is, the rain. Sun heats up the surface of the Earth turns to water vapor goes up, collects into clouds, and it comes back down again. So there's phase transition oscillation as well inside of stars as they evolve. Animal swarming. Animals are a direct result of the formation of life on highly evolved stars, so there's that. Neural circuits, I guess your brain, of course. It's a direct result of star evolving. You do all the little complex things in the past of the Earth. I say here something about directed probabilities. I don't know where I was really going for that. Of course, that's probably for when we start doing supercomputer calculations, where we do a lot of algorithms. So you take different variables and you plug them in, and you say, well, where is this one going? 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 And then you clump them all together in a single spot, and then you redo those probabilities again for another set of events, and then you do a long chain of those types of orders, and then you get the end result. But of course, stars do that naturally, and that's the whole point of this talk. This is number 4, why planets are ancient stars. It's a very big theory. It's far beyond my capacity to do full justice, but I definitely want to give thanks to people like this guy. If you want to watch some of his videos, I'll link a little interview to the bottom of this page, because this guy knew exactly what he was talking about, and he put life in its correct position ahead of the study of physics, which sort of abstracts away the meaning of things. All right, you guys, this video is 19 minutes long. I think it's time to stop. Later.